RF connectors are make or break for any RF design. Your circuitry and your antennas, they can be perfect, but if the connection between them doesn't work, then nothing works. So in this tech chat, sponsored by Mouser Electronics, I'm joined by Paul Hulatt, Group Product Manager at GCT. We'll dig into the clever engineering inside RF connectors, how to keep them alive in extreme environments, and why an IP68 rating on a datasheet should make you ask a couple more questions. Paul, thanks for being here. I'm looking forward to this.
Really looking forward to it. The opportunity to talk about RF connectors is really quite exciting.
So can you give me the RF connector crash course? Who is using these connectors and what sort of environments and designs are they going into?
Well, let's start by saying that RF connectors, RF doesn't stand for really frightening. It's radio frequency. And you think about what you've got in your home, and they're just about everywhere, aren't they? Everything's internet enabled, or data's being transmitted backwards and forwards, be it your mobile phone or even things your vending machine is talking to someone to say, "Hey, I need filling up."
Yeah, I'm just looking around my office here and thinking about how many RF connectors there are just in my office alone. But what about more extreme, like outdoor environments?
Well, if I walk out of the door today, you'll hit some roadworks, which isn't unusual in England, and the temporary traffic lights will have an antenna on them. They're talking to each other by RF. The electricity substation, these have antennas sitting on top of them as well. They're talking back to base as well. We also have in offices next door to us the Environment Agency, and they're monitoring all the time all the river levels, all of the sewerage applications, and just things that you don't even think about. It's happening without you even seeing it. And that's really it's a hidden technology, but it's a very enabling technology.
Yeah, the hidden tech is kind of everywhere. And it seems like the longer I'm in the world of electrical engineering, the more I see the engineering in the world around me as I drive around. So when I see something like an antenna bolted to the light pole outside, what's going on beyond that antenna? How do you go from this like sensitive internal design through and into an external tough weatherproof antenna system?
I think it's important to say that a lot of these devices are enabled through wireless modules. These are standalone electronic devices, and they're available to buy as complete units. These are often pre-certified and ready to go. They can be integrated into many different designs, so an engineer can take them. In some instances, they'll have a ceramic chip antenna on them. More often than not, there's a need to connect them to the outside world using a microcoax. Here you can see it highlighted with the IPEX microcoax connector. Could just as easily be a Hirose type product, and that's what's connecting the antenna to the outside world through a bulkhead. And this is where the challenge comes, because as soon as you start going to the outside world, there's a need for that antenna connection. And if that needs to go outdoors or outside or an industrial application, then that has to be environmentally protected as well. And that's where GCT have tried to bring a solution to bear. When we're trying to go to the outside world and environmental protection is needed, then it's important that the cable selection is the correct one. That could mean choosing IP-rated cable assemblies, and they may have to be isolated. Again, that's another challenge all of its own. And in very harsh environments where chemical resistance is needed, then we have some stainless steel options as well. So this, with partnership with IPEX and all the other options that we have for the microcoaxial plug, enables us to offer solutions for almost any wireless module that exists out there, making us a one-stop shop for people working with those modules.
Do you have any moments from the past where you can recall a time where an engineer maybe didn't spec quite the right part, or people got into the field and got into deployment and it wasn't quite meeting what they needed it to meet?
Well, very often an engineer will find something that's close to what they need online. They'll find it. They'll check it out, and more often than not, we'll have a call. Well, this is almost what I want. Can you make it with a longer thread? Can you make it go deeper? Can you make it resistant to harsh, an agricultural environment, maybe? And those challenges pop up all the time. And we're the sort of people that like to say yes, or we certainly like to look into it before we say yes, because our customers are our best teachers.
Okay, so almost means probably give folks a call and see if you can get get just the right fit.
Absolutely, and the whole team is very knowledgeable about our product range and can help advise on these things. We take great story in some of the application stories, because from that we can derive the solutions, learning from other people's experiences.
So I have to imagine one of the situations where almost right is maybe not at all the right situation is when it comes to like water and dust ingress. Can you talk about how to think about ratings and how to actually design one of these parts to meet those ratings when it comes to like rain or submersion or dust or salt or those sorts of things?
Well, I think to anyone looking at one of these SMA connectors, just looking at the outside of them, the non-waterproof ones can look exactly the same as the waterproof ones. And it's important to understand exactly what you have. If you have a non-waterproof product, then water can migrate through the front face, through the contact, into the cable, and start to cause problems. Now, that may not happen immediately, but over a course of time, that could slowly cause breakdowns and cause a lot of problems in the field, where people have to. Some of these products are in inaccessible places, and a breakdown can be catastrophic, not just because of the replacement, but the inaccessibility of where some of these parts can be found. We started designing waterproof connectors back in 2005, and we could see that more and more people are taking electronics outside. We're being asked for it more, and we started to take these things, take them apart and rebuild them. And you can see on the slide here, certainly the middle slide, the red highlighted area, that shows some of the seals that we install inside the connector to provide that IP rating. The connector in the middle, that's IP rated, but that's for mounting from behind the panel, and the connector on the far right there is for mounting from the front of the panel and secured behind with nuts and washers. And it's providing all of those products tested to an international standard. And we publish those test results. They're there for everyone to see. We don't hide behind a statement. We show people the proof.
Is there an O-ring like around and in contact with the center conductor of this then?
Yes, there is. And that goes through the white dielectric that you go there and around the center contact. And they're assembled to give you a waterproof performance. But it's not as easy as just putting a seal in there, because as soon as you start doing things like that, you destroy the RF performance of the conductor. So there's some clever stuff going in there that our engineers are able to design through shapes and forms and materials that make sure they maintain their performance all the way through the frequency range, right up to 8 gigahertz and beyond.
I never thought I'd get excited about O-rings, but that's really interesting.
No.
That's super cool.
And they are actually red.
Oh, they are red. Okay.
They are actually red in real life, so that's not but yeah.
So what you see is what you get.
What you see is what you get.
Let's talk a little bit about IP standards. I know the numbers mean things. So can you talk me through some of the testing that happens and how, when I look at a label or a sticker or a data sheet, how I can like learn how to read these ratings and understand what I'm seeing?
Okay, so what I've done here, this is a cut down of the whole standard. The IEC standard itself is quite lengthy, but for the purpose of understanding IP, ingress protection, and the first digit, that red digit there, 6, that is for the prevention of dust. Make sure that dust doesn't get through the connector or through the panel and into electronics and cause problems. As you know, dust and moisture can cause shorting and reliability problems. So it is a big issue. The next digit in blue, the 7, that's the protection against water. For most all outdoor applications, people are specifying IP67. So that allows you to immerse the product or the device in water. We test 2 meters deep for 30 minutes. That's your accidental drop into some water or a puddle or a pond or something like that. That's got that covered. But more especially, it's definitely going to cover a rainy day and a stormy day. The IP68, now this is a little bit interesting because the 8 can be specified by the user. You can specify that to be whatever you want. GCT, we tend to say that it's a meter, still the same depth, but for 48 hours, so we extend the time period. Some products go beyond that, 5 meters for 12 hours. So have a look at the product and make sure you understand exactly what it means. If someone says IP68, it's typically a harsher test than IP67, but it means different things to different people. And finally, the 9K, that's to simulate someone pressure washing this. You've all pressure washed your car. So here you are, you're washing down your equipment, piece of industrial equipment or a piece of test equipment, you're hosing it down. And that's what that's meant to simulate. We say 14 to 16 litres a minute. That's a very scientific way of saying you're hosing it down with a pressure washer. So that's what we're trying to simulate. So that hopefully gives you an idea of how you're going to use these products, or not just connectors, any product. You're starting to see these on your cell phone. People drop their cell phone in all sorts of horrible places. They bend down and drop it down the toilet, don't they? Let's be honest. And it's meant to protect it from those sort of accidental drops. You're in your boat, you drop it over the side, and hopefully you can recover it. So not designed to operate underwater, but accidental immersion in water is covered.
There's an interesting note about IP68. I didn't realize the definition was that flexible.
Absolutely. It's a little bit of a misconception, and the more people that understand that, the better. Engineers will come and not just engineers, anyone said, oh, I want an IP68. What they're really saying is we want something that's a little bit more resilient than IP67. Well, then it's a conversation about how is your product going to be used? Is it going to be used and be underwater for long periods of time? Is it going to be to great depths? And by understanding that, you start to understand how we've got to adapt our products or redesign them to give you the application that you need, or the product that you need, sorry.
Yeah, so if you're designing like a deep sea submarine, that connector needs to look very different than like a storm drain water sensor.
Absolutely. You've got it in one.
I just mentioned storm sewers. There's all sorts of things going on under the ground that I only know a little bit about. Can you talk me through some of how these are getting used in like infrastructure and just underground environments?
Let's imagine an application that's underground. It's sometimes underwater. It's in a very inaccessible place. And, imagine the depths of a drain or underneath a drain cover. Here, the customer needed a waterproof SMA connector to give an external antenna connection. But the point here is that this could be underwater. It rains, it could sit underwater for up to 5 meters for extended length of time, if that's in an area that's flooded. That SMA connector had to be designed to withstand that. I don't know whether I mentioned earlier, but our IP67 products go to a meter. They want to go to 5 meters. So it's 5 times more challenging, I guess. But we were able to go away, design a product, look at tolerances, bigger seals, chunkier everything, and we're able to maintain the RF performance. And we were able to deliver something and prove its performance with independent testing. Now, that was something we did about 10 years ago. It's one of the first products we developed. And as far as we know, there's still products out there functioning 10 years later. So that's quite an endorsement to our waterproof products. And that's where IP68 comes in. It's IP68 because it's 5 meters. The next challenge followed on, similar application. They wanted to put it down drains, but this time it's sewers. So similar sort of application, but a much harsher environment. Sewers contain all sorts of nasty things. They call it sewer gas. And typically where there's muck, you shouldn't have brass because brass will corrode. And this is where stainless steel was the solution. We started building connectors using SUS303. It's an easy-to-form material, provides solution for most any outdoor application in a harsh environment. If you wanted something a little bit more corrosion resistant, then that's where SUS316 comes in, the 2 different grades. And you will see 2 different grades out there. Check it out. Some people will say, oh, I've got a stainless steel connector. Well, what grade of stainless steel are you using and what's the application? That's a real litmus test. And certainly if you're going underground in sewers, then SUS316 is where you need to go. But having solved that problem, we then started to discover that people in agriculture and the food industry were also having the same challenges. We tested them to IP69K. People are hosing these things down. You can imagine they've come out of a really dirty environment. First thing they want to do is pressure wash them. And these connectors allowed you to do that. So it extended the use case of the product, but gave you the reliability. Because as we've said already, if you have to send someone out, if something stops working, firstly, if it's in a flooded environment, you can't get there. If it's underwater, underground, it's difficult to get there. And there could be people relying on that data to know remotely whether that's a flooded area, whether that infrastructure's working, or whether it's broken or needs some attention. So reliability is key, and choice of materials is very important to get that right.
Yeah, the stakes are so high for if these things were to break down, just to send someone somewhere they don't want to be to to replace all this.
Well, somewhere they just can't get to because the environment's flooded. We've all seen the newsreels where great swathes of land underground now. So it's not an unusual situation.
Fascinating. I never thought about different types of steel being such an important differentiator, but it does make a lot of sense. You know, tool steel versus something you're like welding with. Very different. Let's go from that environment to something even more tougher. What about like military grade, space grade? What sort of applications are we looking at in that sort of scenario?
Well, this pushed the boundaries even further. The people in the armed forces, whether it's Army, Navy, or Air Force, they're out up there in muck and bullets. These things are in mud. They're being thrown around. They're being shocked. Vibration is running through them. They're dropping them underwater. They're recovering them. They've got to work. Their lives rely on these things working. So this is where we were faced with another challenge. And a military radio manufacturer came to us. Well, okay, we've seen your product. It looks great, but can you give us IP68 for 20 meters for 30 minutes? So here we go. Still IP68, but now we're down at 20 meters. That's about 28 psi, much deeper than we've ever gone before. So same story. We went away, scratched our heads, came up with a design, some new seals again, and we came up with a product. And here you see it with a 4-hole flange, and that's done for strength. These things, as it's been explained to me, if these things are sitting in a military vehicle, if that's the only thing you can lever yourself out of the vehicle with, people are going to literally step up on a connector, an RF connector, get themselves out. They're not
Yeah.
going to think about what they're stepping on if they've got to get out in a hurry.
I've seen that even when they're not in a hurry, like with test racks, someone put a laptop on the top of the test rack and then it became a step to like reach something on a plane or something.
Yeah, I think we've all done things we shouldn't have done, haven't we?
You got to be careful with that. I see the red O-ring there you mentioned earlier also.
Yeah, it's still red.
It's still red.
But a little different application, and the design is different.
Yeah, what an interesting corner case to basically say, hey, we're scuba diving and we need our radios to work.
I think in that instance, it was actually an instance where these things may have been dropped over the side, and they would recover them.
That makes sense.
Yeah.
Okay.
Rather, not necessarily for underwater use.
That makes sense.
Scuba divers or submarine.
Okay.
But we're just waiting for that next phone call to come.
Yeah, from under the ocean. Hey. I thought you said IP68. So we've talked about ingress protection, and I think we've pretty robustly covered the dust and water, but there's more to a connector than just the physical elements. I understand interference and crosstalk can be a concern with these connectors. It is RF, and anything can be an antenna at any time if you're not careful. What do you think about in terms of like actual RF performance and shielding and isolation?
Well, okay, that's best illustrated by another application that I prepared here for you. And this arrived by rail. It's another phone call. Can you help us with? And this was a piece of trackside equipment where it monitors 2 tracks, and it's monitoring the amount of lubrication on the track to reduce the squeal and the noise and the friction. But each track was controlled by a different channel. Each channel had to be isolated from each other. So although it's an outside application, IP67, it just needs to be rainproof, perhaps underwater for a short period of time if it's a real heavy storm. Each channel had to be, the ground had to be isolated to make sure there's absolutely no interference. And that turned out not to just be the case for rail applications. It's something that's a requirement in mines and other areas where safety is critical. And on the next slide, I can show you a little bit about how we did that. The connector itself is a standard SMA or TNC, and the challenge here was to isolate it from the panel or its outer shell. So there was an isolation sleeve. It can be shown in white. It's kind of difficult to see, but we've cut away so you can see that dielectric and insulation sleeve made from dielectric materials, and that isolates the ground from one channel to the next. That is assembled, put together, again done in such a way that it's IP67, so it's suitable for use outside, sitting at the side of the railway, so you're whizzing past on your train and probably totally oblivious. Trains don't squeal anymore because they're lubricating the tracks, and that's all possibly being controlled by trackside lubrication systems, and that's probably talking back to HQ, telling you what's coming down the track, what needs to happen, when it needs maintenance. Hey, I need a little bit of attention here. I'm feeling a bit unloved. Need some maintenance. Come and talk to me, or just monitoring the track, monitoring the trains coming down the line, and telling it what to do.
Interesting. I had no idea that train tracks got lubricated, and it makes sense you'd want to know like which rail even, so being able to isolate your signal and ground for each channel, for each rail, or for each set of rails would be important, so you're not, anytime you have any issue anywhere, you don't want to just re-lubricate everything. You want to figure out when and where the issue's happening and fix it.
And you're absolutely right. We had no idea at all until the customer phones us and say, hey, can you do? And we said, well, I don't know. We'll go away and find out. This was a solution, and they're in use today. And once we'd found a solution, we found more applications.
That's just so wild. Yeah. Normally when I think about ground, I just think about like just connect it to all the casing, the everything, and just get it as grounded as possible. But being very careful with that makes makes a lot of sense.
It's a relatively simple solution, but a complex one for an RF engineer if things are interfering with each other.
Yeah, I imagine that has to be a lifesaver for people who need it.
Absolutely. And this is where, in mining environments where they have redundancy, they'll perhaps have more than one channel, and if one channel goes down, then they'll switch to the next channel for safety reasons.
So making sure that these work every time and have a operational lifespan that matches what you expect it to be. What sort of tests are you running, both like off the production line, but mostly in that design and development phase?
So we test our products internally. We have our own IP testing rigs, but we also use an outside accredited lab to verify all of those results. Taking that one step further, we set about a program to try and simulate the life of a product. And this was done, we consulted with one of these accredited test laboratories and developed a test regime that applied British Standard and IEC testing. This consisted of, started off, we'd mount the products in a waterproof box, as you can see I had a picture there. We'd test them electrically to make sure that they were within specification and to give us a baseline so as we knew where we were starting from. Then we'd spray them with salt water for 100 hours, see what happened, and then we'd subject them to something called thermal shock. So we'd take the connectors from minus 40 degrees to plus 85 degrees, and we'd do that in about 10 seconds, pretty quick. So that's very harsh for anything, the shock that causes. But then we did it for 100 times, just for fun. That starts to simulate what might be happening in a winter environment. You think about how winter might unfold. And then just to confirm that no damage had occurred, we would do further waterproof testing or IP testing at a meter for a further 30 minutes. And then we conclude with some more electrical testing, make sure everything was working properly, and make sure that we were within specification. So that was one cycle, and it's deemed that was about 1 year's life. So we thought, we'll do it 5 more times, just see what happens. And the result of that was that everything continued working. There was no adverse impact on any performance of any of those connectors at the end of that 5-year life. And we have taken that test, we published that for people can see if that resonates with any of the things that they're doing as well. People will be able to find elements of that and apply that to their own use.
Fantastic. I love watching these things come through development and through like the test labs, all the different fixtures and techniques they have in the chamber that, starts with the oven and drops down with like the liquid nitrogen cooling to test thermal shock and compression stuff. It's really, really interesting. What are maybe some learnings or some adjustments you've had to make as a company over the years as you've done these tests and learned some best practices?
I think it's true to say that we have had to adapt to our customers' environment. As you've seen already, we've had to go from 1 meter to 5 meters to 20 meters, and we just don't know where that next challenge is going to take us. But we're up for that challenge, and we're working on things all the time. We started in 2015, and it's a never-ending development program. There's always something new challenges. And I've already said that our customer is our greatest teacher. People are always trying to take these into more challenging environments. And we're here to try and make that happen. And this is a good example of one, actually. We've spoke about remote antennas already, and this is shown a typical use case example where an installation engineer has to mount an antenna somewhere different, away from the main unit. And this is showing an antenna. There's a cable underneath there. You can see just a little bit of a gold-coloured antenna and the cable coming out underneath it. And if you go onto the next slide, what we've done, we've produced these extension cables. But it's really important that even an extension cable as an accessory has the same level of performance. IP67, 68, 69K, and they're sealed, mated, unmated, but also at the cable entry. These products have proper O-rings and seals designed to seal the cable. So they're sealed at both ends, so to make sure that anyone installing these, they're going to be there for a long time. They're going to keep working for a long time.
A system is only as good as its weakest link. So if you have the best connector in the world and the worst cable, it doesn't matter how good your connector is because your cable's going to fail long before anything else does.
That's right. And very often people think just putting a piece of heat shrink over the back of it is going to do the job. But this hasn't got heat shrink in, but there's a whole set of seals in there to stop it leaking.
So I'd be curious to hear also about direct to PCB connections, because that's almost the opposite approach. Is instead of cabling up to an antenna, it's going right into the board itself.
Absolutely. And this is where not everyone's designing with one of these wireless modules. They need the flexibility to do their own thing, shall we say. And this is where we're offering the PCB mount connectors. Again, it's the same standards, the same materials are available. Stainless steel, brass, gold-plated brass, still sealed to those standards we talked about. IP67, 68 a meter for 48 hours, and the stainless steel ones are going to IP69K. But it's also worth saying here that the brass ones use a silicon seal. The stainless steel ones, we have options of a more highly chemical resistant seal made from something called EPDM. And that's something that is also critical to any engineer looking to put these in harsh environments. They'll start to be looking at chemical resistance. That's something we can offer a solution to.
Interesting. I never thought about the seals having to also be as corrosion resistant as the metals. I also see there's some edge launch PCB connectors, which I board over here. Yeah, these are fantastic. Can you talk me through kind of how that might differ from a right angle connector?
End launch connectors, they offer a much smoother transition from the coaxial cable through the panel onto the microstrip or coplanar waveguides on the PCB. They're connecting directly onto the PCB traces, giving a really straight signal path for the RF, so it's got no kinks or bends to go through. It matches the impedance, reduces the insertion losses, and we're now offering these up to 18 gigahertz, still IP67, so something a little bit different there, and hopefully some of the use cases will resonate with engineers designing to higher frequencies.
So we're getting into millimeter wave grade technology here that can also still be IP67 rated and
absolutely
live out,
and
in the weather.
And as I said before, it's not just about putting some rubber seals in there or some silicon seals. There's some clever stuff going on with the design as well to keep that performance.
So if someone is looking to design with these connectors, where do they go? What should they think about? And what sort of resources are available for them?
We like to think that we're an engineering-led organization. I hope I've demonstrated some of the challenges we've solved. But having solved them, some of the performance and reliability issues, you can see that specifications is really non-negotiable for engineers. And nowhere is this more clearly demonstrated than across our waterproof connector range. Sealed and staying sealed is our absolute commitment. We work with key partners like Mauser, really, to make sure engineers can find all the technical information they need. Drawings, specifications, 3D files, their online test specs, test reports. It's complemented with the inventory supplied, and it's complemented with inventory from Mauser to support those early production trials. So our aim is really to help engineers confidently choose and evaluate the right connector cable assembly quickly and with confidence. In other words, we're not just providing parts, we're trying to provide confidence and support for the engineers at every stage of their design.
And like you mentioned earlier, you also will work with people for custom connectors. Are there any other moments or any personal favorite times where you got a weird phone call and you're like, okay, we gotta get creative here, but we'll make it work?
Turning that question another way, I think I've given you an example of some of the challenges we've had, some of the weird phone calls that we have. And I think the real challenge sometimes comes in not just solving it for one customer, but thinking about how you can apply that to other applications. Products found on the railway now find their way into other environments, underground and mining environments, oil, gas rigs, and things like that. So it's a slightly different twist on your question there.
No, that's a really good. That's a really good answer, and answer like an expert product manager.
You're too kind.
Awesome, Paul. Do you have any parting wisdom or thoughts for engineers who are starting to dip their toes into the world of connectors, or maybe need an RF connector in the future?
Well, for me, the real challenge is that you may look at a connector like an SMA connector. It looks like a relatively simple part, but what keeps it really interesting for me is the number of different applications you can find that in. Anything from rail to military radios to data loggers that go underground to your traffic lights. And it's all those applications that keeps things really interesting and gives me a real buzz.
Paul, this has been wonderful. Thank you so much for being here today.
It's been an absolute pleasure. It's been fun talking to you, Daniel.
That was Paul Hulatt, Group Product Manager at GCT. And to find the right RF connector for your next design, go to mouser.com/GCT. I'm Daniel Bogdanoff. Thanks for tuning in to this Tech Chat, sponsored by Mouser Electronics, and I'll see you next time.